Epoxy or polyurethane? It's a defining decision for any manufacturing facility floor. But what if one of these coatings could last twice as long in your highest traffic zones? The differences are stark. One withstands boiling water, wash downs, the other fails completely. The right choice isn't about which is better, but about analyzing your operational demands. We'll break down durability, environment, installation, and application to build your decision framework. Let's start with durability. Epoxy is known for one thing: incredible hardness and compressive strength. It supports massive static loads like presses or CNC machines. But this hardness is also its primary weakness. Epoxy is rigid with low elasticity. Vibration and impacts cause micro-cracking and eventual failure. This is where polyurethane excels. It's flexible, acting like a shock absorber. It endures impacts from forklift traffic without cracking, distributing the stress. Abrasion resistance. Polyurethane is significantly tougher against the scraping and friction of heavy traffic, lasting up to 10 years. UV stability. Near a loading dock, epoxy will yellow and chalk. Polyurethane maintains its color and gloss. So, it's epoxy's hardness versus polyurethane's flexible durability. How do they handle heat, chemicals, and moisture? What is the single most common, yet overlooked reason an industrial floor fails? It's not what you think, and it's already in your concrete. We'll reveal it shortly. First, heat. The huge difference in thermal shock resistance is molecular. Polyurethane's elastic chains expand and contract with the concrete. Epoxy's rigid structure cannot, causing it to lose its bond and delaminate. This is why a hot washdown that blisters epoxy is routine for a PU floor. The same principle applies to chemicals. Polyurethane is particularly inert to organic acids and caustics, a requirement in food and beverage facilities. Now back to that silent floor killer. It's moisture vapor transmission from the concrete slab. Epoxy isn't breathable, so hydrostatic pressure pushes it off the floor. Understanding these failure mechanisms is key. Now let's map these properties onto real-world zones within your plant. Where does each coating belong? Epoxy zone. Think immense static weight, under heavy machinery or in tool rooms. Here its compressive strength provides a rock-solid foundation. Polyurethane's zone. Think movement and abuse, forklift aisles and loading docks. Its flexibility and abrasion resistance are non-negotiable here. Another clear polyurethane zone. Any area with thermal shock or organic chemical spills. This includes commercial kitchens, breweries, and chemical processing areas. The choice seems clear by zone. But what about the practicalities of budget and downtime? Here the decision gets more complex. Let's talk money. On a square foot basis, epoxy often has a lower upfront installation cost. But this is a classic trap. Factoring in polyurethane's longer life and fewer repairs, its total cost of ownership is often lower. Then there's downtime. Certain polyurethane systems cure much faster, getting your facility back online sooner. This complexity brings up an important question. What if you didn't have to choose? What if you could combine their strengths? This is the hybrid system. It starts with an epoxy base coat, which is excellent at filling small cracks and forming a powerful bond with the concrete. Then a polyurethane top coat is applied over the epoxy base. This top layer becomes the wear surface, taking all the abuse. This top coat gives you the flexibility to prevent cracking from scene 7 and the abrasion resistance for a 10-year lifespan from scene 9. It also delivers the UV stability to stop yellowing from scene 10 and the thermal and chemical resistance we explained in scenes 13 and 15. You are combining the foundational strength of epoxy with the superior durability of polyurethane. This is a strategic optimization. So the best choice is often a system. Before you decide, 2 final factors can derail any project, no matter which system you pick. First is surface preparation. The moisture issue from scene 16 is a symptom. Insufficient prep will cause any advanced coating to fail. Your foundation is everything. Second, be aware of new formulations. Look for low VOC options and new technologies that offer faster curing to meet modern standards. The choice requires a detailed audit of each zone in your facility. Analyze traffic, temperatures, and chemicals to make a long-term investment. To help, download our free facility floor audit checklist. It's a step-by-step guide for an informed conversation with your flooring contractor.